Hi, my name is Miguel Ángel Ontiveros Alvarado. In this video, I will talk about chromatography in column. We will do an experiment with things that we had at home. We only need ethyl alcohol. In this case, it's known as ethanol, a syringe. We won't use the needle, so we just remove it. Cotton. Oh, where's the cotton? Cotton and cornstarch. This will help to separate and do the chromatography. Also, it's recommendable to use an air pump or something like that to give us energy for the separation. And I almost forgot the colorant that is the thing. Okay, before doing the experiment, I will try to explain the fundament. We shall know this because it's pretty important that we know what's happening in the experiment to enrich the knowledge and try to support the way of learning in an easier or a recreational way. I hope we learn everything that I can offer in this video. But, well, this chromatography can separate the components of a mixture based on their properties, how they interact, and the distribution between the stationary phase and the mobile phase. That is the main thing that can have a chromatography in column. Yeah. Okay, talking about this stationary phase, this is matrix or a resin with functional groups that interact with our analyte or with our sample, whatever you want to call it. You can select it based on their properties like hydrophobicity, polarity, or electrostatic charge. The mobile phase is the solvent or eluent. Most of people call it eluent. Can be a buffer that dissolves the sample and transport it through the column. The affinity is the capacity of interaction between our analyte and the stationary phase that goes through the mobile phase. This analyte will take too much time to travel through the column if the affinity is high, because it's more, like closer, like they had a relation, a strong relation. You can separate easy. You will cost, it will cost to you a lot of time, a lot of energy, and this is why we search that the stationary phase and the analyte doesn't have a high affinity. The lowest, the better. And the stationary phase is like a solid in most of the cases. In laboratory, we use silic. It's the most common. And this technique is too good to separate or purify compounds. In addition, the amount of stationary phase that we will use, it depends in the separation that we need to perform or the size of our column. Sometimes we use 100 grams of absorbent per gram of product to be separated. It is necessary that you understand the parts of the experiment. We should remember that the parts of the fundament work pretty well if you use it pretty well, or you choose it better. Before starting the experiment, I will try to explain why we use this material. First of all, we had the syringe. The syringe is going to be our column. We just remove the needle because we won't use it. We will not use it, but don't throw away the plug too. The plug is one thing that we will use if we don't have an air pump. The air pump will work better, but if you don't have one, just use the plug. It will work too. Then we have the ethanol. The ethanol is selected as our mobile phase because it has characteristics as the polarity, and is not expensive. It's quite I don't know how to say it. It don't cost that much. But okay, this will go through the stationary phase. In this case, is the corn snatch. The corn snatch is a stationary phase that will separate the compounds that we are going to use. In this case, we are using this marker as our vegetable colorant because I don't have colorants here, but it is easy to use it. We only need to extract a little of the color. Then we have this and this. First of all, we use the ice cube palette to put our extractions with the drops that we will extract. Then we have the cotton. Okay, we will start with the experiment. First of all, we need to remove the needle and the plug of the syringe, or our column. I will refer it as our column because it's what it is. Then we need to cut a little piece of cotton and do it a little like this. Then we put it in there, and with a pen or a pencil, we try to plug the hole that is in our column. Try to stuck on it because it will prevent the stationary. Well, it will prevent that our stationary phase go away. And like this, it needs to be really in, like this. I don't know if you can see it, but it's like this.
Please.
After that, we need to fill the column with corn snatch. We need to be pretty carefully because it's too messy to fill it. I recommend if you can use a filter or something that helps you, it is preferred. We will fill it not too much because it can last our extraction too much time, depending in the amount of stationary phase that we use. I say you need to fill it 1/3 part, and then you need to do this little movement to flatten it into it, like this.
Yeah.
Okay, this next step is called activation. The activation is when you put in the first time your mobile phase and go through your stationary phase. But this is without the analyte or the substance that we're going to spare. This will activate the activity of retention of our stationary phase. I already done it, so take a look. This is the ethanol and this is the corn. So just with the plug, carefully drop the first drops in your ice cube palette like this. I will try to show, but we need to put a little effort. And there are our first drops. Once you start this step, your stationary phase will not dry. Take that in account because it's a very specific step and it's pretty important. An important note to say, when you use the plug, when you are pulling out, the stationary phase will pop up. Let's try to remove the plug and with the help of a pen or a pencil, pull it back in it. We have to be pretty careful and flatten it with too much care, and again trying to pull it all the way down like this. I don't know if you can see the drops that are coming out. With the plug, this will happen a lot of times, so be patient and do it carefully, as you can see. To extract the color of the marker, we need little pieces of cotton, and with the marker we will color like this, both sides, everything that we can, and then in a bowl like this we will put in, and with ethanol just a little bit like this, and stretch the cottons to make the color go out. Try to do a saturated solution of color the best that you can, and then we have the color. The next step is adding our colorant. We need to do carefully, trying all to go into the tube like this. And we will see this. Then with the plug we need to push all the way down, trying our colorant go through the column. Some drops will drop, but then there's no colorant, so pick one bit of the ice cube palette and wait. When you see here, change the color, change the palette. Remember, always add mobile phase. We need not to dry, so take care a lot of that. And I'm doing faster, but you can pause the video and see step by step while I'm doing. So we do this and all the drops to one palette. I will show you the result of this extraction, but it consists in this. It also check, there's a color right here, the first color. That means that is the affinity, the lowest in all the compounds that we're going to prepare. Well, this is the technique of chromatography in column. As you see, it's an easy way to extract and isolate some compounds of a mixture. I didn't extract a lot of colors because the colorant, it wasn't powerful. But if you can find vegetable coloring that is in a little bottles, you can combine those colors to form another colors, and then you can do the extraction, and it will be pretty nice and pretty visible effect. I will put some pictures at the end of this video.